In this video, we will be reviewing similarity with algebra mixed in. So in problem number 1, we're all set up to do the angle bisector theorem. I see that this angle is being split in half right here. But I need to know what this little missing side right here is. So Noah, this little missing side, did you find it?
Yeah.
What is it?
It's 64.
All right. That's going to be 64. Of course, he did 104 minus 40. That's where he got the 64 from. So then, according to the angle bisector theorem, we can make a fraction out of these two and set it equal to a fraction out of these two. So you would have done something like 40 over 55 is equal to 64 over 12x plus 10. Now I like to reduce these. What is 40 over 55 reduced down to? Like 8 over 11, I think. Nobody reduces except for me, so that's why nobody's answering. So 12x, and you don't have to reduce, internet people, but I recommend it. So then I'm cross multiplying. So I'm going to do 8 times 12x plus 10 is equal to 11 times 64. So of course, what's 8 times 12? 96. And then what's 8 times 10?
80.
Okay. And then what's 11 times 64?
704.
704. So then I subtract 80 from both sides. Okay, so now I have 96x is equal to, what's 624? Scooch it a little. And then I divide both sides by 96. And what's that?
6.5.
All right. So that's how we're getting 6.5. All right, so on problem number 2, this is a little bit strange. We're going to go ahead and solve for x first, and then we'll find y afterwards. So looking at the x, we're going to use the Side-Splitter Theorem. All right, so I'm noticing that the x, Miguel, looking across the shape, the x sort of corresponds to which?
8.
Okay, that sort of corresponds to 8. All right. Now over here with the x, I see this 28 sitting there. All right. Now, what does the 28 correspond to? This is a little bit of a trick question, but what does the 28 correspond to?
24 and 8.
24 and 8. That's the perfect answer. So we need to go ahead and put those together to make up the number that goes with the 28. All right, so put those together for me and tell me what you get.
32.
So we get 32. So I have 32. So the 28 corresponds with the 32. So those are the 4 numbers that we should be using to help us find x. All right, almost any logical way that you make an equation out of those 4 numbers is going to be okay. There's like 8 different ways you could do it. So go ahead and give it a shot. Give me an equation.
X over 8.
So I could do x over 8, for example.
And 28 over 32.
And then 28 over 32. Okay, so that would work. Any questions on that so far? All right, so I'm going to reduce this. So both of these are divisible by 4. So x over 8 is equal to 7 over 8. That kind of tells me right there that's going to be x equals 7. But 8x is equal to 56. Divide by 8. X is 7. All right, now let's find y. All right, so Nancy, we need an equation that involves y. All right, can you help me out?
2y plus 6.
2y plus 6.
Over 28.
Okay, that sounds good so far.
28 over 32.
Okay, you're using the right two numbers.
Oh, 32.
32 over 28, right? Because if we do bottom over top, then we need to do bottom over top again. So we have to do 32 over 28. Okay? And then we already know that that's going to reduce down to 8 over 7. So this is going to be 8. This is going to be 7. All right, so when I cross multiply, I'm going to have 7 times 2y plus 6 and 8 times 21. So this is going to be 14y plus 42. What's 8 times 21, somebody?
168.
168. Then I'm going to subtract that 42. All right, so what's that going to be?
126.
126. And then we divide both sides by 14. And what do we get?
9.
9. All right, any questions on number 2? So looking at problem number 3, we're given that triangle FGH is similar to triangle DEC. So because we know that, then we know that angle F is going to be congruent to angle D just because of their place in the similarity statement is corresponding. So angle F is going to be congruent to angle D. So angle F is 63, so that means angle D is also 63. Similarly, angle C is going to be congruent with angle H because they are corresponding. Angle H. So angle C is 56. So that means angle H is also going to be 56. All right, now the sum of all three angles in any triangle we know is going to be 180 degrees. So if I subtract these two from 180, hold on. Close enough. So if I do 180 minus, what were those other two angles? 63 and 56. So minus 63 minus 56. Okay, that's a little bit off camera. I'm going to get 61. So that tells me that the missing angles are both 61. Any questions about number 3? All right, in number 4, we're given that triangle RST is similar to triangle KLM. Similar, not congruent. So one triangle is bigger and the other is smaller. Now, the angles will still be equal. The angles will still be congruent. So this is a true statement. But the corresponding sides are not going to be congruent because this is bigger, this is smaller. So these are bigger sides, these are smaller sides. All right, explain what's wrong with the, okay, I guess I basically already explained what's wrong with the other side. Yeah, so these triangles are not congruent, so the sides will not be congruent. I mean, you can see I have a bigger one and a smaller one. Okay, for problem number 5, we're supposed to compare these two pictures and talk about how the differences change the similarity statements. So the only difference between picture A and picture B, in picture A we have a 6 and a 7, and then in picture B we have a 7 and a 6. All right, so let's start with picture A and decide which one of these similarity statements is going to be accurate. So let's match up the corresponding sides. That's going to be key. Look at the top triangle. Which is the smaller side in the top triangle? Anybody?
PQ.
Right. All right, to see the 12, that's the smaller side. All right, what's the smaller side on the other triangle?
6.
The 6. All right, so those are going to be the corresponding sides, the two smaller ones. So obviously the two bigger ones, the 14 and the 7, those are going to be corresponding sides. All right, we know that these vertical angles are going to be equal. Now when it comes to the other angles, look at angle T. Do you think angle T is going to correspond with angle Q? Or do you think angle T is going to correspond with angle P? It's going to correspond with angle P. You can tell by the way the corresponding sides are reversed. Okay? Ramon, head up. So, the T is with the circle. The P is with the circle. So you know those are going to be corresponding angles. In the same way, this Q is going to correspond with this S. All right? So, does that make sense so far? Noah, does that make sense? What I said? Ah. All right, so angle P corresponds with angle T. So I see P in the front, so I should see angle T in the front. So that's happening on the bottom one here. So I already know that the bottom one's going to be the answer, but I'm going to keep going for one more step. Angle Q, we already decided was corresponding with angle S. So angle Q is next, angle S is next. So clearly this one is correct. Okay, does that make sense, you guys? Okay, now when you look at picture B, let's do it again. 12 is the smallest and 6 is the smallest. Those are now corresponding. 14 is the biggest and 7 is the biggest. Those are corresponding. All right, so the vertical angles are still equal, but now look at angle T. Which angle is angle T going to correspond with now?
Q.
Can you see that it's going to be Q? All right, because you see the 12 and the 6 on the same side. So it's not reversed. It's not flipped around backwards. All right, and similarly the S and the P are going to be corresponding. So let's see. So angle P is now corresponding with angle S. So I see angle P and angle S are both first. So I can tell this is going to be the answer. But let's do one more. Angle Q with the double mark corresponds with angle T. Angle Q and angle T are both second. So you can see that this is going to be the one. So I could describe this by saying the sides on the smaller triangle are labeled 6, 7 for picture A and 7, 6 for picture B. Because the corresponding sides are reversed, the corresponding angles are reversed. All right, for problem number 6, we're given that triangle DEF is similar to triangle HGF. So, bless you. So use vertical angles to label one more angle measure. All right. So we see the vertical angles here, so this will be 61. We know that triangle DEF is similar to triangle HGF. So angle E is going to be congruent to which angle? Anybody?
G.
G. All right, because they're both second in the similarity statement. Okay, so since E is 54, then that means G is also going to be 54. Sum of all the angles in any triangle is 180. All right, so to find the missing angle, we're just going to subtract from 180. So if I do 180 minus, what were those two angles again? 54, so 54 and 61.
Yep.
Then I get 65. All right, so the missing angle must be 65. So this is a continuation still of problem number 6. So now we're talking about sides. So triangle DEF is similar to triangle HGF. Okay, so I'm going to leave Dylan alone for another second because he's still settling in. Welcome, Dylan. Shout out to Dylan. Juan, segment EF corresponds with which segment?
GF.
GF, all right? We see EF are the last two, GF are the last two. So corresponds to GF. Okay, so I think I'll color those just to, let's see, so EF and GF. So here's GF, I'll put a circle on it. And here's EF, I'll put a circle on that. All right, now, use your answer above to help you fill in the boxes in this proportion and then solve for X. Let's see. So obviously the 36 and the 27 are corresponding. So Miguel, X over what?
32.
32 is going to equal 27 over 36. All right, and we know how to solve this. I like to reduce, of course. So let's see, 27 over 36. So 27 over 36. That's 3/4. So this will be X over 32 is equal to 3/4. So when you cross multiply, you're going to get 4x is equal to 96. And then when you divide both sides by 4, what do you get? Do you guys get 24? Right, just
Yeah.
double check me. I'm doubting myself now. We're going to get 24. So in problem number 7, they gave us all this good information. So I've started a picture for you. Label the vertices of the second triangle, S, T, and U. All right, so this will be S, T, and U, all corresponding with the P, Q, and R. Now label the side lengths that you were given. So PQ is 24. So I've got a 24 right here. QR is 30, so 30 goes here. ST is 20, so there's my 20. And SU is 28, so there is 28 right there. Now put an X on side TU and set up and solve a proportion to find it. So of course the X is corresponding with the 30. So I can go X over 30 equals, and then the 20 is corresponding with the 24. So I can go 20 over 24. This is going to reduce, so I'll have X over 30 is equal to, let's see, so these are both divisible by 4, so that'll be 5, 6. All right, so when I cross multiply, I'm going to get 6x, and then 5 times 30 is 150. And then if I divide both sides by 6, I get x equals 25. So number 8, explain with words and numbers how you can tell these rectangles are similar to each other. Think about scale factors. So can anybody help me with that? How can I show that these triangles are similar to each other? Nick?
Find the scale factor.
We can find the scale factor. All right, help me set it up. How do I know which sides are, well, I guess we can just see this, how they're
6
corresponding.
over 8.
All right, so looking at these corresponding sides, all right, we have 6 over 8. What does that reduce down to?
3 over 4.
All right, That reduced down to 3 over 4. And then what?
9 over 12.
So corresponding sides 9 over 12. And what does that reduce down to?
4.5 over 6. I don't know. Well, I don't know what
Okay.
9 is.
Well, they're both divisible by 3 is the idea. So, or you could put it in your calculator. But if I divide both of these by 3,
3 over 4.
I'm going to get 3 over 4. So, since the sides are proportional, or since you get the same scale factor, or since you get the same ratio for both pairs of sides, they are similar. Okay, so that's how we could explain with words and numbers why these two rectangles are similar. All right, so using that as a roadmap, you can see what I'm going to do to show that these rectangles are not similar. Right? So Cameron, what am I going to do?
Set up an equation.
Set up an equation. All right, let's start with these corresponding sides. So like 3 over 8. That doesn't really reduce, so we can just stop there. And then looking at the other corresponding sides, we have 5 over 12. That doesn't reduce either. So these are not equal. So since you get different ratios for both pairs of sides, they are not similar. Problem number 9. Given triangle LMN is similar to triangle PQR. Now, silly Susie made a mistake. She started by writing 5x plus 24 is equal to 48. All right? Who can explain to me why this is incorrect? Crickets. Come on, people. All right, JJ.
Susie doesn't understand that the lines are not, they are similar, not congruent.
Right, these triangles are similar, not congruent. If the triangles were congruent, then the corresponding sides would be equal. But here we have a big triangle and a smaller triangle, as you can have when triangles are similar. So the corresponding sides are not going to be equal. They're not going to be congruent. Let me write that down. All right, so the triangles are similar, not congruent, so the corresponding sides are not congruent. All right, fill in the boxes in this proportion, then solve for x. All right, so in number 9, we should have had, so we have 5x plus 24 over 48, and of course that's going to equal 63 over 56. And I always like to reduce these. So, of course, 63 over 56 is 9/8. Okay? So when I cross multiply, I'm going to be doing 8 times 5x plus 24 is equal to 9 times 48. All right, so that's going to give me 40x plus 192 is equal to 432. All right, subtracting 192 from both sides. That's 240. And then divide both sides by 40. And you get 6. All right, any questions about number 9? So in problem number 10, Oliver Oopsie made a mistake. He started by writing 3x plus 14 equals 8x plus 4. But this is a mid-segment situation. So UV is obviously not going to be equal to the parallel side. The mid-segment is going to be half the length of the parallel side. So let's see, I'll just say UV, segment UV is a mid-segment. So it will be half the length of TS. Okay, it should be half the length of segment TS. So I like to say 2 halves equals a whole. In fact, maybe I'll just write that down over here. 2 times a half equals a whole. That's the idea. So that's why a correct equation would be 2 times 3x plus 14 will equal 8x plus 4. So that will make 6x plus 28 is equal to 8x plus 4. I will probably subtract 6x from both sides to keep the x's positive. So then I have 28 is equal to 2x plus 4. Subtracting 4 from both sides, we have 24. Please stop making that whistling noise. I'm recording. Will equal 2x. Then I have to divide both sides by 2. So that's going to give me x equals 12. So number 11, Rhonda Wrongo made a mistake. She set up this proportion. X over 27 is equal to 16 over 36. Okay, so if she's doing 16 over 36, she's clearly trying to do the side-splitter theorem. But the side-splitter theorem only works for sides. So the mistake happened when she went and tried to do x and 27. All right, so that's why she failed here. So what she really needed to do was to draw the triangle separately and do new over old equals new over old. All right, so I'll just write a little sentence here. All right, so the main problem is this 16 right here. This little 16 is not a side of any triangle, so it can't be used. And we'll see that by drawing the triangles separately, you'll see that 16 will not show up anywhere. So looking at the small triangle, I see that I have 36 and 27. So I'll have 36 here and I'll have 27 here. But looking at the large triangle, somebody help me out real quick. What's the length of this big side right here? 52. 52. So obviously we're adding those together. So this large side here is 52. And then, of course, we have the x. Notice the absence of a 16. The little 16 is not a part of any triangle, so it should not show up in the proportion. So I'm going to think of this triangle as new and this one as old, and I'm going to do new over old equals new over old. So that would be x over 27 is equal to 52 over 36. And that reduces down to 13 over 9. So now I have x over 27 equals 13 over 9. So when I cross multiply, which I think I'll put over here, I will get 9x equals okay, 351. So of course then I will divide both sides by 9. So you get 39. So in problem number 12, we're given these similar triangles. We got the little triangle by dilating the larger triangle, shrinking it down. And they're asking us which is the scale factor. So we really could just pick a point to use. So I'm going to pick point P. No, I'm not going to pick point P. That looks like it's between the lines. Maybe I'll just pick point R because that's just so simple and easy. So point R starts off at, what's that, 5, 0, 3, 4, 5. So point R starts off at 5, 0, and then it becomes point R prime, all right, which is the new point, which is at 2, 0. So focus on the x values, and the scale factor, which I always call k for some reason, is always going to be new over old. All right, so in this case, the new is 2. All right, the prime is always the one that's new, and the x value, the old value, is 5. So the scale factor should be 2 over 5 because we have to do new over old. You'll always know which one is new. I'm trying to squeeze it in here. You'll always know which one is new because the prime is new. All right, the one with the little marks on it, that's the one that's new. Okay, in the scale factor, where did the 2 come from? Where did the 5 come from? All right, I think that covers it. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.